Good day, sir. Good day, dear juries. My name is Yuvan, son of Ramdas, from Faculty of College of Engineering from University of Malaysia of Pahang. My title of the project today is Combustion Monitoring System. I myself is the inventor of this project, and the co-inventor of this project is Associate Professor Dr. Devarajan Ramasamy. So now let's look at the background of my project. So basically, my project is a study of combustion process in an internal combustion engine. So why do we do this? Is to improve the performance of the engine. So how do we study the combustion process? Flame speed is used to study the stability of combustion process in the engine. So it is not easy to study the flame speed of the combustion process in an engine. So we use a simplified setup of a non-compressed air-gas mixture in this project, which it uses LPG gas as the fuel. So this is the simplified setup of our project. Okay, so the idea is to determine the flame speed of the combustion dependent on the fan speed in the test rig. So to do this, how do we detect the flame speed? We use ion sensor to measure the flame speed. So finally, once we get the flame speed, we compare the experimental result with the theoretical book value. Okay, let's go to the problem statement for this project. What's the main reason we are doing this project? Okay, the main reason of this project is observation of an internal combustion process is a difficult issue. So this is due to the conditions such as speed of piston, pressure by compression, heat of combustion. So it's not easy to research a full operating engine. So that is why we are using a simplified setup in our project. So the objectives of our project is to design an ion probe to measure the flame speed, and the second objective is to analyze multiple probes for accurate detection of flame speed and compare it with the real engine data. So let's move on to the project scopes. Project scopes are understand operating system of an internal combustion engine. Then next is to understand how does air-fuel ratio affects the flame speed of the engine, which is the engine performance. Then next is experimental study of ionization flame. Then later is analyzation of the result. Okay, that's all about project scopes. Now let's move on to the methodology of my project. So how do we do this? First of all, we fabricate the multiple probe circuit board. The next is test the circuit board using multimeter. After that, we design the probe using solid bolts first. Then later on, we fabricate the probe, which is the iron probe. Next, we install the iron probe to the engine block, the test rig that I've shown earlier. After that, we connect all the components, DAQ, power supply, circuit board, and terminals accordingly. Then next, we test run on the engine block. After that, we collect data and capture the flame using DSLR camera for further use. Later on, we analyze the data and do some calculations, and finally we compare the obtained result with the real engine data. So before that, let me explain what is an ion probe. An ion probe is a device which used to detect the electrical conductivity of the air-fuel mixture and the engine. So when the air-fuel mixture gets ignited by the spark plug, the flame will go from the top dead center to the bottom dead center. So the flow of the flame is detected by the ion probe, and a small electrical signal will be sent from the ion probe to the oscilloscope through the circuit. Okay, so that's it about the ion probe. So this is the working principle of the ion sensor, which is available in the current market. Take a look at this. Okay, let's see how the calculation is done. The calculation is basically a simple method. In order to calculate the flame speed, speed formula is meter per second. So we need distance divided by time. So how do we do this in the test rig? In the test rig, we insert two ion probes at a specific distance. So we calculate the distance between the two ion drops, then we take it as label it as D1. Then we divide the distance of with the time taken for the flame to travel from ion drop 1 to ion drop 2. Time taken is obtained by by calculating the peak of the graph in the oscilloscope. So when we do this, we obtain distance over time, which is meter per second, which is the flame speed of the flame. So from the testing, the flame speed that we obtain is a laminar flame speed. Then we compare this flame speed to the turbulent flame speed from the real engine, because the real engine gives out turbulent flame speed, and the test strip that we are using here gives out laminar flame speed because LPG gas is a laminar flame. So therefore we compare the ratio of turbulent flame speed to laminar flame speed and compare it with the book value. So that's it about my project.